Good morning. I'm going to continue on Steve's talk about finding the spaces. This is a new field for me in what the discussion is going to be. So we heard today so far, let me flip forward here. We heard some about the science and research. We heard some about the technology that together those are going to help us reach more sustainable phosphorus use goals. But as a sub-team, what my group worked on was actually looking at how to use a deliberative process to develop a more robust strategy to influence accelerated change towards sustainability. So when I say accelerated change, I mean all of you on Red Bull, okay? So moving forward, caffeinated, and trying to reach some goals. So looking at this side here, I have this up here to show that we've historically used this process throughout history in many different situations. This example on the screen is looking at adopting water treatment to eradicate waterborne diseases. So thinking about how can we learn from past events to ameliorate the rate of how we reach a solution. And so by speeding up this process, we can help to prevent some of these unintentional consequences. This process is actually part of a defined framework that's been studied across the world, and it's actually called Transition Management Framework. I want to make sure that it's clear that when I say management, I'm not referring to one person in a hierarchy saying this is how you manage something, but more of an intentionally driven plan, so like a planning process. There are 3 levels. We're going to begin looking at, is this cut off? Okay, good, it's not cut off. At a regional level. All right, so these regional dimensions here on this red pentagon, it symbolizes having an open, linear phosphorus system. Each of these points on the pentagon, they signify or represent some sort of social dimension, and depending on where you are, that social dimension may be more important than another. And so I think about what Mike was talking about earlier, about some of those ecosystem services. Well, depending on where you are, one of those services may be more important than another. There are various transformation pathways, so that fancy animation there, that we could take in order to move toward a more sustainable, circular, closed system for phosphorus sustainability. When we think about it at that regional dimension, we have to also play into the scale, the landscape, or the global perspective and the pressures that we may be seeing at that larger scale, okay? And so this squiggly line with some ups and downs, those are those global pressures, all right, those landscape pressures. And I'll talk about what we might consider as we're dealing with some of the more regional dimensions. And then lastly, at this micro scale, this is where we are, as in you here, the mobilizing actors in the room, where we fit in. So we can look at how we've contributed research and data as niche actors to develop innovative technologies that we need in order to be able to adapt to this transformation of the phosphorus system. So I symbolize this as a change in these circle sizes to show, all right, here are our individual innovations, right? Here we are as these individual niche actors, but if we join forces and establish coalitions, we become a bigger force. And so we'll talk about that, and I'll have some additional examples. An example where transition management has accomplished a solution to a perceived problem, well, a problem that it was perceived that there was no solution to, it would be too big to accomplish, took place in the late 1800s in Netherland. where they actually moved from cesspools to an underground sewer system. It actually took 50 years, and most of the time was actually devoted to identifying what the challenge was. It moved forward as a hygiene problem. The mobilizing actors involved were the working class families that were throwing the garbage, had these cesspools. Their waste would be going out onto the streets. There were doctors then that came forward and not just saw the filth, but they could smell the filth, and they related it to some of the epidemics that were taking place at that time. So kind of like that first picture that I showed of the eradication of the waterborne diseases, that same sort of thing was happening. And so by having the right players involved, it moved into, there was more awareness. There were the political and the public officials started to become involved because there were these pressures to reform. And that's what ended up causing the shift to the sewer system. So it wasn't necessarily the drainage problem, but the hygiene problem. And you can imagine at that time, the 1800s, what a heavy capital investment that was. But by following this process that's diagrammed here on the screen, and I'll go through each of these steps coming forward, by following these steps in this right order, they were able to address the problem and come up with a solution. I'm from Minnesota, as Jim mentioned, hence the accent. And so I decided that I would take some data that I have here within Minnesota and try to show you those fun animated pathways, how those pathways actually can lead toward the transition. And I'm doing that here by, if you see on your left, the y-axis, that's the phosphorus use efficiency. And you'll hear phosphorus use efficiency in a number of different ways. But the way that I'm representing it here is specifically looking at corn. And it's the phosphorus that's removed by harvested corn divided by the phosphorus fertilizer input. So if you see where there's the 1, that would mean the system's in balance. If it's higher than 1, we're mining the soils. And that's represented by that solid black line. I want you not to look too closely at the dips. Those are things that are being influenced by climate. Okay, so those, if there's a drought, we're going to see a decline in what's harvested. But pay more attention to the trends, and those trends, those different segments, where there's T1, T2, T3, T4. That's where if you just kind of look at the general slope where we're going, that's what I really want you to pay attention to. Now, if we look at the right side, that's the phosphate fertilizer price index. That's what I want you to think of as that landscape pressure, the global scale of the importance, what may be causing some of these changes. Okay, so if we have the price weighted down on some of the regional issues, then we're going to see some change taking place. So if we look at the transition 1, just going through what happened, this is when there was, again, a global increase in phosphorus or phosphate rock exploration that created a landscape change. There was a supply chain demand because that was the post-war baby boom time. Population was increasing. We needed more food. There was a demand for food. The actors were the fertilizer industries, the land grant institutions that were looking at the work that Mike does, the soil test phosphorus, and then also the agricultural producers. Now at that time, there wasn't a focus on the over-application of phosphorus. There was the soil test level, and they said, you know what, add a little bit more phosphorus to guarantee our yields. Okay, so keep that in mind. So we had a decline in the phosphorus use efficiency. Whoops. Okay, transition 2. At that time, we saw an intensification of phosphorus, but at the same time, there was a realignment toward more phosphorus use, or more efficient phosphorus use. Why? Because there were political players Why? Because we became aware that phosphorus was a limiting factor toward eutrophication. So that's when there were some of the first studies in Lake Erie linking phosphorus to eutrophication. So all of a sudden, it got the political actors involved. What are we going to do? Well, our perspective on soil test phosphorus started to change. We started to reevaluate how phosphorus was being applied. At that same time, so I love how history can play into a story, but looking at it, there were these niche innovations that were taking place as well. There were new crop genetics. We were getting increased yields. We were being able to determine which kind of seeds were going to be able to use the phosphorus more efficiently, or the crops. And so that was transition 2. At 3, we had more regular change. There was no external landscape pressures, but that continued niche innovation. And so that was increasing harvesting efficiency, so larger tractors were available. We began to mine soil phosphorus. We became more focused on being efficient. And then lastly, what we've seen more recently, the external pressure of T4, that increased price of the rock, so the fertilizer costs went up. We began to be even more efficient at applying phosphorus. We began to look at how we're applying using precision ag and crediting manure phosphorus. So I introduced this diagram earlier with that Netherland example, but now I'm going to actually go through what does it mean at each of these stages. So first, the eutrophication of water bodies. That's our first challenge. At the same time, we have this finite and disproportionate phosphorus reserve. We need to move forward to that next step, which is developing partnerships and also mobilizing actors. In order to have the momentum to move forward, to see change, we need the right actors at the table. When I say the right actors, that doesn't mean we have to all agree, because conflict is sometimes what causes these further discussions, which end up leading to change. And so we want to encourage discussion and have all the right people around the table. This is what leads to the innovative solutions. And also, we can then come through that with some additional funding sources so that we can continue the research to come up with some of those solutions. Lastly, evaluating and learning. By monitoring on the landscape, looking at phosphorus fluxes from water quality, food waste, the biosolid application onto the landscape, we can identify if we're making change. We can look at evaluating policy effectiveness. Are our new policies working? And then quantify the innovative practices that are being adopted onto the landscape. So in summary, potential disruptions on the horizon may require urgent action, so we should be prepared. Drink your Red Bull, right? Transition management may be a way to plan for it in an integrated, collaborative way. We are here, right? You are here. You are the niche innovators and motivated actors in this room. Coming together, we all play a role in the transition management framework. By meeting here today, we're starting this process of transition management, and by continuing this coalition, we can move forward toward a more circular economy with phosphorus. Thank you.
Thank you, Heidi. So we certainly have time for some questions and discussion at this point, so happy to field them.
I was fascinated by that presentation of your phosphorus partial balance, use efficiency there, and it looks very interesting, particularly the response to the price spike. I'm just wondering how long you would expect that bump in efficiency to be maintained.
That's a great question. And, you know, when I think about the role I play in the research world, and then also at the Department of Agriculture, I think about how we'd like to continue that. I mean, not necessarily that spike in the price, but thinking about being more efficient. And I think that I like to believe that we'll continue to be efficient in our use, but at the same time, we have to be aware that we can only mine the soils for so long. And so that alone is not going to be sustainable. That's when thinking about the spreading of the manure is important, because you can only, there was that diagram earlier from China of looking at what the levels, the Olsen P levels were in the soil, and we can only mine it for so long. And then, but by having soil test levels and paying attention to those, and having precision agriculture to know what in each area of our fields, what is the phosphorus level, we can continue that, to be efficient and add when it's needed. And so, does that answer your question? So we don't have an exact time scale, but I think by using the innovative technology we have today, we can continue moving toward efficient use.
Thank you, Heidi. Regarding the diagram there for the transition management, I just want to understand some of the steps there. I'm looking for
This
where...
one here on the screen? Yeah.
The one you're showing there. So I'm picturing where identifying actions and implementing the actions fits in. Is that with the mobilizing key players? Does that imply also where the action fits in?
Yeah, I think that so where an action fits in is going to depend on who's brought to the table, right? Because the perspective may change depending on, if we're leaving out the producers from this discussion, then we may overlook something that can lead to, again, as was mentioned earlier, an unintentional consequence. And so knowing when the innovation should come into play within a timeline and be used to address the problem, and think about it holistically to make sure that, as we saw earlier, that we're thinking about the whole system and all the inputs, and how one decision, one new innovation, how it may affect something else. We want to make sure that our system stays in balance. And so I don't know that I'm addressing your question directly or answering it directly, but I think that it plays a part in that, developing the partnerships, but also mobilizing those key players to make sure that we're having that discussion, so that we're not leaving out any important aspect of the process and the problem.
Heidi, I wanted to ask you something. So last spring I ran a workshop, an NSF workshop here with some other folks, focused on technologies that are limiting our ability to measure phosphorus in water and in soil, like to easily measure phosphorus availability to plants. So this Olsen P thing that's been around for so long, that everyone relies on, it's laborious, it's slow. Do you see, if there, one of the parts of that workshop, and others in the audience as well, who are in the production side of things, what is going to happen to help us get a better way to measure high resolution, highly spatially resolved phosphorus availability in soil at different depths, and then of course on the loss end as well? Does anyone out there have ideas about that, or how we're going to get there? Because Olsen P just seems like 1937 or something like that to me. It seems like we need to go faster, especially if we want to have a precision application approach with phosphorus in the system. Anyone?
I want to hear the answers from all of you first.
Paul, you have some secret phosphate meter, I hope?
No, I don't have any secret phosphorus solutions, but I think it's important to remember that the current soil testing has been calibrated against yield response trials for many, many years, going back 30, 40 years. So, If you're going to try and introduce a totally new test, then you have the problem of recalibrating that test. So maybe the best solution would be to adapt the current tests to make them more precise. And Mike mentioned the buffering capacity I think is a key metric to perhaps include in that.
Yes, I think my concept is more along not necessarily that the test is imprecise, it's just that it's slow and hard to do, and high resolution in the field, and also in high timescales to be able to run a tractor for somewhere, right, to be able to put the P in the right place. How are we doing? Okay, so we're going to move on. Sorry. So please, if you have ideas or things that I don't know about, please let me know about them. I'd love to hear more about progress that's being made in that area.